2.1 is going to cover increasing, decreasing, and piecewise functions along with applications. So objective 1 is a pretty lengthy title. It says, we're going to graph functions looking for intervals on which the function's increasing, decreasing, or constant, and then estimate their relative maxima or minima. Maxima and minimum are just a plural for maximum and minimum. So you actually aren't supposed to say maximums, you're supposed to say maxima, which is kind of interesting. So it says on a given interval, if the graph of a function rises from left to right, it's increasing. So it's just kind of like your typical line if we want to kind of look at it that way. So if you have like a positive slope is kind of how we say it, that would be increasing from that part of the interval. And then just vice versa. If the graph drops down from left to right, it's said to be decreasing. So linear functions are either increasing or decreasing. They're not doing both, all right? But sometimes we can get into crazy functions and they might do all three things. So the third thing is if the function just stays the same, it's just going to be a constant function. So it's just like a horizontal line, all right? So let's look at these three functions that we have going on here. Notice from here, this point to this point, or this point to this point, it doesn't matter. If we go from A to B, in general, didn't we go up, right? And so if we had to say that was a line, and it would have a positive slope. So it's increasing on this interval. And it looks fancy, but they're just using generic A for X, so then the Y value is f of A, right? That's how you'd find a Y value. And then they're using B for their second X, but again, they're plugging it in, finding f of B is their Y value. The middle one, guys, is just showing decreasing. As we move from A to B, we're just going down as far as the Y values go, and so it's a negative slope or a decreasing part of the function. And then left to right, A and B, both the Y values f of A and f of B are the same, so it's just constant. How we tell increasing or decreasing is using baby domain, okay? So for example, on what part are we increasing, guys? We're increasing from like A to B. So you'd write it like a domain from A to B, and you always use like open intervals. We always are going to be using parentheses there, and I'll show you how we do that in a second, okay? The next topic, other than increasing and decreasing, is relative maximum or minimum, and that's just in general, in the neighborhood, it's your highest point, it's your max, or it's your lowest point, it's your min. So they get all wordy, but let's just see what it says. It says, suppose that f is a function for which f of c exists for some constant c in the domain of f. F of c, so notice that's the y value, okay? The y value is a relative maximum if there exists an open interval containing c such that f of c is bigger, right? It's taller. So it's just your high point, okay? Your max is just your high point. And then minimum is just the flip of it. F of c, so again, it's your y value that we're talking about, is considered a relative minimum if there exists an open interval I containing c such f of c is less than it. So it's your low point. Hills and valleys, okay? So look at the picture that's down here. The reason why they say relative is they just mean in a little interval, like in a neighborhood. It doesn't mean it's the highest point. So like if you look at this graph, do you guys see how it's going up in both directions on the side? So it's going to go higher than this guy, right? But he's considered a relative maximum because like in the small little neighborhood, isn't that point the highest point? Yes. And we don't necessarily know what this graph is going to go do, so it might go up and then come back way down. Who knows? So these aren't the minimums, they're just relative minimums. So the y values are the actual max or min. So like this point could be 4, 8. The maximum would technically be 8, happening at an x value of 4. And we'll talk about that with some specific values. So let's go ahead and look what's going on. So we are making you graph, okay? So follow along with me. I thought about copying and pasting. I'm like, no, this gives them a little bit of doodling to do. It kind of keeps them busy. Let's graph this function. So the first point we're going to graph, guys, is -1, -2. So plot that point, -1, -2, and label it -1, -2. Let's plot all the main points first, and then we'll draw the graph. Our next point we want to plot is 3, -2. So let's count over from the origin, 1, 2, 3, and then go down to -2. And we'll label that. That is 3, -2. And then the next point we're going to plot is 5, 1. Okay? So So we're going to count over 5. 1, 2, 3, 4, 5, and go up 1. And we'll label it right above it, 5, comma 1. So with these 3 points, something different is going to be happening in each chunk. This is what a piecewise function is. A piecewise function is a graph that's made up of different chunks, okay? So it doesn't have to be exact. I don't really care where you're coming down through, but kind of do like this half arch shape down into your first point. So kind of just do that half like arch shape down to your first point. And then any guesses are what we're going to do from our first point to our second point since they're on the same y value. Just go straight across, right? So try to shade this like level here, straight across. And then what we're going to do is we're going to do an arch. So we're going to do like an upside down U. We're going to go up to 5, 1, but then we're going to turn around and come back down like that. So if they asked us domain and range, we would be able to answer the domain and range since we have arrows, right? Do you guys agree this is going up and to the left forever and down and to the right forever? So our domain, we're going to cover negative infinity to infinity. Our range is going to be exactly the same, right? We're going down forever to negative infinity and up forever to positive infinity. So really, if you think about it, there's not really a maximum or a minimum. So we're going to talk about increasing, decreasing, constant, but we can even talk about max and mins here if we needed to. We're going to do it on this one though, okay? So on my math lab, they're going to ask for the intervals in which you're increasing. So it gets kind of tricky, but hopefully I can do my best to clarify. When it comes to increasing, you're looking at your y's, right? You want to see where your y's go from low to high, but you only say from what x values do you do that. So do you guys agree that this is going down, so that's decreasing? This is going straight across, so it's constant, but from here to here, we're going up, we're increasing. But they just want from what x to what x. So at what point did we start increasing? We started at 3, make it open, okay, with an open parenthesis. And then when did we stop increasing? At 5. Do you guys agree with that? So it's like baby domains, right? Domain is as you look left to right, what x values are you covering? So when we're talking about increasing, decreasing, and constant, we say, okay, from what x values are we increasing? We're increasing from x values of 3 to 5. Why are they open parentheses? Because really at 3, depending on what direction you go, it's either increasing or it's constant, right? It's not really included. The same thing with 5. This was 5, 1. At 5, it's increasing leading up to it, right? But then you turn around and it's decreasing. So it's not really ever included, okay? So with increasing and decreasing, your intervals are always parentheses, all right? How?
Do you ever use brackets?
No, not for increasing, decreasing, or constant. We're always going to use parentheses, okay? So we'll just say that. Always parentheses. Because at that point, usually something is changing. So like depending on what direction you're going, it's like I don't know which one it is. So we just say let's go till 3. We start at 3-ish and we go to 5-ish, but we're not including those. All right, decreasing. Do you guys agree that this first arm right here is a decreasing, right? From left to right, we're way up here, and then we come down and we stop here. So technically, what x value goes up and over forever? What x value is that? Negative infinity. But where do we stop? What x value? Negative 1. And then I'm going to put a big union there. I'm not too sure if the book, or excuse me, my math lab uses unions or commas. Just pay attention, I'll tell you. Because we're also decreasing on another interval. Where else do we decrease on this graph? Starting where? Yeah, so starting at 5, we're decreasing and going to what x value? Technically, it's going down forever, but it's going to positive x's forever, right? So that's going to positive infinity. And like I said, it's a tricky concept because increasing and decreasing, you're thinking of highs and lows, and so you're thinking of y's. But when you go to write the intervals, you're always writing intervals of x's, okay? We're always writing intervals of x's. All right, and where are we constant? Do you agree if it's from negative 1 to 3? So we'll just know it's always x to x. So where did we start and where did we stop as far as x goes? All right. So the next one, we're actually going to use our graphing calculator to graph it first to get it plotted on here, but we're going to use this feature where it will tell us relative max and relative mins so we kind of know what ones to plot. So I told you guys to get your calculators out, but I forgot to get mine out. Okay. So in your calculator, it's always dark. I hate this though because then there's like a big glare. All right. In our calculator, we're going to turn our calculator on and we're going to go to our stat plot and make sure we turn it off from yesterday. So you hit second y equals, and see how my plot is on from yesterday? I'm going to hit enter, and then I'm going to scroll over to off and hit enter so it's officially off. Because sometimes when you go to graph and you have your stat plot on, it won't graph for you. It'll say error because your stat plot's on. All right, so all of our stat plots are off, so I'm going to hit second mode, and I'm going to go back to my main screen. Second mode is always quit. It gets you back to that main screen. And we're going to graph this function right here. Remember, f of x is a fancy way of just saying y equals. So hit your y equals button and type in that function. 0.1, x is right here next to the alpha, raised to the third power, minus 0.6 x, and then the square is just over here, minus 0.1 x plus 2. All right? Then I'm going to hit graph, and it might be a little off because it says invalid dimension because it's using the stat plot stuff. So I'm going to hit zoom. Oopsie, second quit, sorry. I'm going to hit zoom and standard. Oh, is yours working? Let me get out of there. I tell you to do all the stuff. Oh, I have another plot on, that's why. So that's why I'm saying if you have a plot on, it's always going to say something's wrong. So I'm going to graph it. And it should graph kind of like a curvy looking guy. Does that look okay? Let me know if you're not getting it to show up. Okay. Let me see. So we're going to go to our y equals button and type in our function.
On plot 3, right?
You just do it y1. It doesn't matter what plot you're on. I don't know what the different plots are. So just go ahead and down here, type that. So 0.1, and then that's your x always. And then this will raise it to any power you want. So I didn't hit it, so sorry. And then there you go, to the third, perfect. And then arrow back over, and then minus 0.6 x squared. Arrow back over, and then minus 0.1 x plus 2. And you should be able to hit graph. And then, okay, so your stat plot might be on too. So it's always what's tricky when you go back. Yeah, so our plots are on, so we're going to turn those off. And then this one was on too. And this is what's going to be tricky with you being in stats and college algebra at the same time. We got to make sure we're doing that each time. Okay, so see, it's kind of using the scale that we had yesterday. So if you hit zoom, oops, it's still graphing. If you hit zoom and then standard, it'll always kind of get you to that normal 10:10 viewing window. Okay. Brayden, did you get yours to show up okay?
Yeah.
Okay. Gavin, did yours show up?
I don't know what I'm doing wrong. It just doesn't it just won't show.
Okay.
I've done
So we'll
the
hit zoom and then standard, so 6.
Oh, I was
Because
pressing
9 will
9.
do the stats. Yep.
Okay. Yeah, now I see.
Yep. So the zoom standard, guys, always gets you to that normal negative 10 to 10 viewing window. So anytime we're doing like college algebra stuff, like graphing lines or functions, we want the standard window. Zoom 9, though, from yesterday, will get us to that stats part when we're doing like a linear regression. All right, so what we want to do is we want to be able to sketch this guy. So let's kind of roughly sketch it, noticing that it crosses the x-axis halfway between 1 and 2. So we'll try to do that, okay? So let's cross the x-axis roughly between 1 and 2. Negative 1 and negative 2, I should say. And then it looks like it has a high point around 2, okay? So, and it's kind of like at 0. Again, we're going to get a little bit more specific, but we're going to kind of cross it at 0, 2. And then notice we come back down, and it looks like we cross it right at 2, okay? So we're trying to do this arch movement, and we're going to cross right at 2. And then we kind of have this low point right around 1, 2, 3, 4-ish, and then we go about to negative 2. So let's plot roughly 1, 2, 3, 4 down to like -2. So we're going to go down to him. And then where do we cross again? 1, 2, 3, 4, 5. I'm spinning on my calculator. Oh my gosh. Okay, almost to 6. So it looks like we cross at 1, 2, 3, 4, 5, almost to 6. Like that. Okay, and it doesn't have to be perfect because here in a second, we are going to be able to label all those points. All right, so you guys have like a rough idea of that snake. Basically, we have a snake going on. We're trying to make it cross the axes where we think it's happening. We'll learn a little bit later how to figure out those crosses, but what we care about is right here. It wants us to come up with our relative max and our relative min, meaning what is our high point according to this part. So your high point, your relative max is just your peak, right? Your peak, and then your relative min is your valley. So do you guys agree that it's happening around here and it's happening around here? The question is just what is that exact number? So we're going to use our calculator. So I don't have this typed up. So it's one of those things, if you have questions, ask me later or maybe review this lecture video. In order to find the relative max or min, see right above this trace feature, it says calculate. Do you see that, guys? So we're going to hit second, calculate. And then right here at numbers 3 and 4, we can either choose maximum or minimum. I would choose the maximum first because your graph kind of goes left to right and our maximum's occurring first. So I'm going to go down to maximum and choose it. Okay, so notice it's right around where the maximum is, all right? So what we have to do is we kind of have to tell it the neighborhood. We have to go a little bit to the left. So see how it's asking, is this your left bound, question mark? No, we want to go a little bit to the left. And it doesn't matter where exactly you are. Notice I'm kind of even going on the downhill slope. That's fine. And it says, do you want this to be your left bound? Yes. So I'm going to hit enter. So just move your cursor a little bit to the left of your peak and hit enter. And notice it kind of put a marker right up top and saying, okay, we're looking at a maximum starting here. So then it wants to know where your right bound is. Move your cursor, go up, and then once it starts to go back down a little bit again, say that's a good right bound. So hit enter. Notice it put a marker up top above it. And then this part always makes me wonder. It says, guess, question mark, meaning do you want it to guess, aka calculate what the max is? And we do. So you have to hit enter one more time. So you hit enter once to get your left bound. You hit enter a second time to get your right bound, but then you have to hit enter one more time, and it thinks. Right now it's thinking, and it actually tells you the point right there of where the maximum occurs and what exactly it is, okay? So on our graph, we're going to label it here, but then we're also going to write it over here, okay? So on our graph, we'll label, let's just label -0.082, and then our y value will be 2.004. So when we drew this, we knew it was happening around 0. It's pretty close to 0, so it's negative 0.082, comma, and the y value was at 2.004. Okay, and notice that's pretty darn close to what we graphed. We graphed it around 0, so negative 0.08 is basically 0, right? And we had it cross around 2, and notice it's crossing right around 2, just a little bit higher, okay? Then what we're going to do is we're going to use our calculator again, but we just want to find out what this minimum value is. So what I do is I kind of move my cursor that direction. Oops, no, I lied. We're going to do second trace again. Second trace. And now we say, okay, now we want to find the minimum. So we're going to hit 3, and you move your cursor down on its little way, and you kind of do what we did before. The minimum is the low point, so make sure your left bound's slightly higher on the left and slightly higher on the right. And it doesn't really matter how close it is. So I'm going to just hit enter here, and it put my marker up here. That's fine. And I'm going to move my cursor down and around, and when I start going back up again, I want to make my right bound. So I hit enter one more time. And notice again, it has these markers up here that says, okay, I'm looking between these two x values for the low point. So the last time it says guess, question mark, we say yes, guess, and it's thinking, and it found that low point for us. Did you guys get 4.08 and a y value of negative 1.60?
Yep.
Okay, so we'll just label it. Let's maybe do like 3 decimals so we're just a little bit more accurate. So this mark was 4.082 comma, negative 1.604. So I went a little lower. Looking on my graph, it looks like it went down to 2. But since our graph isn't exact, negative 1.64 is about halfway between negative 1 and negative 2. So we maybe drew it a little low. That's fine. Now that we have those labeled, though, guys, we are going to be able to answer all the questions they want. We're going to be able to say what the relative maximum is, what the relative minima is, and then since those points where they change, we'll be able to say where they increase and decrease, okay? So let's start with the relative max first. What we want to take in account, and I kind of wrote it over here, but on this front page, I made you note the relative max and the relative min are the y values that are occurring at the x values. So when it wants to know what your high point is, do you guys agree that this peak over here is our high point? Yes, but what part of that peak is the maximum? The y value. So our maximum is 2.004. And that occurs at an x value of negative 0.082. So your actual maximum is the y, where it occurs is the x. So the x is kind of like stay in your location. Like, hey, over here at negative 0.082, I have the high point. But what is the high point? It's your y. So that's why right above f of c I said the y is the max, okay? So knowing that, what's our relative min? Well, where's our lowest value? This valley here, but what part of it is the actual minimum? The negative 1.6, you got it. So we're going to put the negative 1.604, and where is that occurring at? X equaling 4.082. So my math lab's probably going to ask you that way. They'll say, what is the relative max? And you put 2.004. Where does it occur? At x equals negative 0.082. All right, so that is just the first part. So the first part says, use a graphing calculator to determine any relative maxima or minimum of this function. And then determine intervals on which the function's increasing or decreasing. So now that we have these labeled, your max and mins always occur where you go from increasing to decreasing or vice versa, right? It's always kind of where that you change directions. So once we have them labeled, we can do like we did up here and do the x to x as far as our increasing interval and our decreasing interval, okay? So I always do increasing first. All right. So do you guys agree that we have two spots where we're increasing? This chunk of the graph as we move left to right is going up, and this chunk of the graph as we move left to right is going up. All right, so let's focus on this first. I know it looks like it's going down forever, and that's correct, okay? But if you're moving left to right, it's technically going up. But if it's going down and to the left forever, what x value shows to the left forever? Negative infinity. And then where do we stop increasing? At the maximum. And what was that at? Negative 0.082. So don't forget, increasing and decreasing, we're looking at the y values, but technically when we say where they're occurring, it's from x to x, right? Always x to x. Always x to x. All right, but I'm going to put a union symbol there. I don't know if my math lab uses a union or a comma. We also have this chunk of the graph. So this chunk of the graph, where do we start increasing at what x value? The 4.082. Are you okay with that, guys? And then we're increasing, when do we stop? According to this graph, we go on forever, right? So it's increasing until infinity. Do you guys see where those numbers come from? So it's just like baby domain. So domain would be left to right. What all x values do we cover? So this domain is technically negative infinity to positive infinity. But when it talks about increasing or decreasing, you shrink your domains. You just look at the parts that's increasing. So this is negative infinity until this point. This point goes to a negative 0.082. And then we start increasing again at 4.082. And then we go on forever to positive infinity. Where is it decreasing? Just that middle chunk. So where do we start decreasing? At that x value of negative 0.082. And where do we stop decreasing when we get to our valley at an x value of 4.082? Is that okay, guys? So we're just decreasing in this little chunk here, but we only just talk about intervals from x to x. So from negative 0.082 to the x value of 4.082, our y values are going down low.
So you can tell if it's decreasing or increasing by which way the arrow's going.
Yeah, so, and not necessarily the arrow, just as you look at your graph from left to right, what would you say the slope of that would be, right? This would be a positive slope, this would be a negative slope, and this would be a positive slope. So, and I can go back to it, because the definition is kind of tricky, but what it is as you move left to right, what is your graph doing, right? So as we move from left to right, our graph is going up, right? So that's increasing. As we move left to right, what is our graph doing? It's going down, so that's decreasing. So our arrows are kind of tricky because this arrow basically means I'm going down and to the left forever, and this means I'm going up and to the right forever. But even though we have a down arrow, technically this is an increasing part of our graph. You see what I'm talking about? Like how it can get tricky, like your arrow doesn't necessarily say it. Is that what you're asking? These arrows right here?
Yeah.
Yeah, so that arrow to me looks like it's going down, so you want to say decreasing, if I'm understanding what you're saying. But what it is as you move left to right on this graph, what are your y values doing? They're technically getting higher and higher, so it's increasing.
Okay.
Does that kind of help you? Like, just go like this. As you move left to right, is the y going up or going down?
It's going up.
So it's increasing. And as you move left to right, are your y's going up or are they going down? Going down, so it's decreasing. And as you move to the left or right, they're going up. So that arrow makes sense, right? Because when we go left or right, it's going up and that arrow's going up. But that arrow makes you want to say decreasing. But really, as you move left to right, this whole function's going up.
Okay.
The arrows just mean like this graph goes on forever, basically, is the way to show it. Are there any questions? Like I said, it's tricky because like when we talk about increasing, decreasing, and relative max and min, you think y, but the location is always based on your x's. All right, so what are some applications? Like why would we care about where a graph has a max or where a graph has a min? It's because you can have real life situations where when you come up with a function that represents that real life situation, it has a max or it has a min. I don't know why I'm putting that away. This is a problem right here I'm going to do with you. Okay. So it says, given an application, find a function that models it, but then find the domain and also graph the function. So in this one, we don't end up graphing it. We'll graph it on another one. So this one we'll just do, and then we'll kind of use it to help us with the second one. Okay. So it says, a man plans to enclose a rectangular area using 80 yards of fencing. So we're getting an idea of what shape we're dealing with, a rectangle. If the area is WU yards wide, express the enclosed area as a function of W. Write kind of small because I feel like we have a lot to kind of fill in here. So there's a rectangle. There's his little yard that he's going to fence in. Do you guys agree with that? And they're telling us to use W for the width. So typically the width is the smaller part. What we do not want is to label length L and we have two variables floating around, okay? So believe it or not, we have enough information just with this information to write it in terms of W, which is kind of tricky. We have this whole idea of perimeter. Do you remember what perimeter means?
Just all around.
All the sides around, right? So if we have this W, what is this over here? It's the same, it's W. And typically what would we label this? L, is that okay? We'll do it for now, but then I'll fill it in. So I always tell my students, so I teach this in Math 111, I say don't memorize formulas for perimeter. Just remember perimeter is just add up all your sides. But a rectangle has the same formula because you always have two lengths and two widths. And so the perimeter formula is actually 2